My name is Nicolai Josuttis. You might have heard my name. I'm currently writing a book about C++20. It's almost done. Only 700 pages. Just 20. And I have a chance to talk 1 hour about my favorite examples. Are the favorite examples always good? So nice? No. You will also see some traps. Oh, I'm not allowed to say traps. I have to say pitfalls, because these traps were not intended. Well, some things were intended by design, but for a good reason. So let's see what we have. Let's start with concepts and ranges. Assume you want to implement a simple function that adds a value into a collection, a generic function. So any collection can be used, any value can be used as long as things compile. Here we use pushback, so which means it will only work for collections that support pushback. So calling this for vector, and you push in a value that fits, like here, 42, it's a vector of int, works fine. Good. There's a new way to write that. The way you can write that is that you declare the parameters to be auto. This converts a function into a function template. It's not a function anymore. It's a function template. It's just a new, shorter syntax to implement function templates. So it's a shortcut for the thing on the right, except that the thing on the right has a name for T, or T1 and T2, while the thing on the left has no name for the type T1 and T2, the type that auto represents. As it is a function template, all rules apply as before. For function templates, usually you put that in header files. Also, the definition in header files, you don't need inline to declare it in a header file. Yeah, that's it. Good. Well, this does not work everywhere. So let's overload it with another function template, calling insert. That should be used for containers that don't have pushback but support insert. Unfortunately, nothing compiles anymore. Why? Overload resolution kicks in. Overload resolution says, I have to decide what to call. There are two add functions. The compiler does not look at the body, so all it looks at is the declaration. The declarations are the same. Return type is ignored, by the way. So there's no rule to prefer one over the other, so the compiler says this is ambiguous. Okay, how can we solve that? Well, stop making them ambiguous. Give them different signatures. There are various ways to do that. One of the most nasty way, or nastiest ways we have, is enable if. Who has used enable if in the past? Who likes it? You are fired. Nobody can like it, because it creates unreadable code. Kidding. There's a better way now to do that. And the better way is place a constraint to the declaration. So here, the constraint we use here is has pushback. So the collection we pass, which is still generic, that's why you use auto here, you cannot skip auto here, has a type constraint. It has to support pushback. Where comes this magically has pushback from? Where from? Well, this is what we have introduced in C++20, a concept. So you can define a concept. Concept is not for code generation. Concept is to decide whether something can be called or not, whether something is available or not. So here we define that has pushback specifies that has pushback is satisfied or met if pushback can be called for a value type of this collection. So as you see on the right, that's what we call a requirements expression, we formulate requirements here. Well, there's an implicit requirement. Our type we pass, our type call, has to have a member value type. And there's an explicit requirement. For this value type, we have to be able to call pushback to put it in the container. So, three things work together. On the right, you have requirements. On the left, you have a name for these requirements, and you use them to constrain your generic code, these three terms. You have to carefully not mix them. Okay. That's it. And you know what? It compiles. Both compile. The effect is that, well, if a container does not support pushback, the first template is not visible. So only the second one is visible. So that's the case if we use a set of int, so we call insert. But for a vector, both are visible because we have not constrained the second one. But there's a rule. The first one is more specialized than the second one. And that means that this is preferred for a vector. So the vector will call that, which is the right thing. Again, note that this is equivalent, that you use generic code using template syntax. There, you could qualify the template parameter directly with has pushback. Has the same effect, but you have a name now for it. And please note one more thing, a little tiny thing here. If you look on the top right, colon value type. So what we learned sometimes the hard way is, if there's a template parameter and you have a member that is a type, you need type name. Do you see type name here anymore? No, because in some places, well, everywhere where it's clear that its member has to be a type, this type name is no longer necessary. One place is this, in C++20. Good. You can write this code in different ways. So another way to write it is to say, oh, let's formulate the requirement not to qualify the type of the first parameter. Let's formulate a requirement. Well, this is not a requirement. This is a constraint. We use the requires keyword for two things. Formulate requirements, that's what we do on the top right. Formulate constraints, that's what we do in the middle left. So we constrain that the type of call has pushback. So we can use auto here. Oh, you can combine this requirement with other requirement. So I require this and that and that and that. That is why you can also use this syntax. Oh, but wait a minute. This does not compile for vectors. You get a crazy error message. The error message is, I cannot call insert for 42 in a vector. Which means the first one is not available. So obviously the second one is called. Any idea why? We pass the type of the collection to has pushback. What is the type of the collection? It's a vector reference. Yes. So what you call here is vector reference colon value type. That's not valid code. Well, that's not an error, because requirements work the way, if code is not valid, the requirement is not met. So we don't see this template. We only see the second one for a vector in this case. Yeah. Okay, so things are not that easy. Well, and one way to remove that is to fix that is to say, let's remove constant referenceness from this type. We have a new type trait for that, a type function. Because so often we just needed that, remove referenceness and constantness and maybe volatileness. That's a new one. And then it works fine. But maybe it's better to do the work to make the concept more flexible. And to do that, you can put it in the concept. So you can say, instead of qualifying the type and then going to the member value type, let's use a helper function, a new helper function of C++20 that helps to deal with ranges and their types, which is stood ranges value type, which will even deal with references. For that, you need a header file. Can we formulate this differently? Yes, of course. Everything you can formulate in 1,000 ways in C++, even simple examples. So instead of doing that, because this requires that the type on the right, the type of the value we'll put in has the same type as the collection. So that would mean we don't support implicit type conversions. Let's do something better. Let's use not has pushback. Let's use can pushback. Can pushback now takes two template parameters. One is the collection. One is a template parameter, the type of the value. And here we don't need any references because we can directly formulate it what we want to have. We want to have support that you can push back the value into the collection. Please note, again, a requirement, a constraint, a concept is not generated code. So there's no need to declare the parameters in the requires expression with be a reference. Yeah, it's fine to make them values because nothing. This is only to clarify whether other things should compile. Good. Again, if you really like to use auto, you can do it that way. You can also put the requires clause after or at the end of a declaration. By the way, this even works for member functions in class templates. And that way, here you can say, give me the type of the collection, give me the type of the value. We already have names for them, so we pass them over and formulate this thing. We can formulate this thing with other constraints, which we add by combining and also in the requires clause. Different ways to formulate requirements, to formulate constraints, I should say, but also different ways to formulate requirements and concepts. So forget that. Don't do that. Don't do that. This is a bad example. You should not use a concept for each and every member function you use in your code. If we would do that, we would have requirements for big functions where we have, does it support pushback? Does it support size? Does it support the star operator? Does it support that the star operator returns a Boolean value? And so on. You would just more or less mirror all the statements in your requires clause, so as a constraint. So don't do that. Just create more coarse-grained concepts. We've done that in the C++ standard for you, so you can benefit from that. We will see that in a moment. But as I said, do that. What you see here. But this is so cool. If pushback is supported, let's call pushback. Otherwise, let's call insert. So do we have an alternative? Yes. Formulate the requirement ad hoc, where you need the constraint. It has a constraint. This is funny. This is requires in your code. But please remember what you learned. One requirement is for a clause, for an expression, for a defines a requirement. The inner requires is to formulate a requirement. And the outer requires is to say, I want to have this as a constraint for my code. Now it makes sense. If you just read the example, you say we are all silly. No, we are not. And we like to reuse keywords for different things, because each new keyword breaks code. Is there a better way to do that? Well, remember that the signature is the same for both adds. So the difference is only in the body of the function. So there are some rules. A rule is a requirement is a Boolean value, a compile time Boolean value. A constraint checks for compile time Boolean value. A concept is a name for a compile time Boolean value. You can use it like a const x for bool. So we can do the following. We have a compile time if. So in the body, we say, if pushback is supported, call it, otherwise call insert. Nice. It's almost reflection. Not really, but it's okay. I know how often I want things like that. Good. Yeah. Oh, let's make something wrong. Let's pass a string. Oh, let's declare that the elements are strings and pass an int. You see the error on the bottom. So you have so far seen that concepts are used to decide which function should be used to fix overload resolution, whether a function is available. But there's another reason we have that, and that is to make error messages more readable. Because you find problems in your code when you call it, not deep in the deep darkness of your code. So if you do things like that, you get a crazy error message. Yeah, there's something broken. Well, oh yeah, in line 500 or 600 of the implementation of a set, we have a problem. We have no known conversion from constant to const. Eh? Okay. So yeah, I'm pretty sure you have seen error messages when using templates which are not understandable, or which you understand once you have found the error. It should be the other way around. So can we benefit from that? Well, here's the error message. Sorry, I'm always a little bit behind because I see the next slide here, and I forget that you not see the next slide yet. Okay. Good. Yes. Formulate a constraint. Formulate the constraint that the value we want to insert with pushback or insert is convertible to the element type of the container. That's it. And here you use a standard concept. By the way, we also use here a standard concept to say the collection has to be arranged so that we don't call it for an int, and that we get early error messages here. Here in the declaration. In the declaration, we see that some precondition is broken. And so the error message could now be something like this. Yes, there's a problem with that, but the candidate template is ignored because the constraint is not satisfied. And the constraint that is not satisfied is that convertible to evaluated to false. By the way, compilers are working on good error messages with broken constraints. Currently in Visual C++, the message is a constraint is broken. You have no idea which, you have no idea why. They are working on that. So if you see this video later than in summer 2022, it's not a problem anymore, I promise. I hope I can promise. Good. You might even find some details. Good. Okay, what time is it? Good. Favorite examples. Let's now use these examples. So now let's use this benefit from that in ranges and views. A library we can use that uses concepts a lot. And here's what the library can do. instead of calling sort for begin and end, you can now do what you have dreamed about for 20 years. You can pass your collection as a whole to sort. And unfortunately, you need a different namespace for some conflicts we have. Yeah, backward compatibility is a nightmare, and it gets worse and worse. And yeah, but now you can pass the thing as a whole. And the good thing is, this library that now takes the range as a whole uses concepts. So the declaration of this sort says, for example, the range must be a random access range. So a range where we can jump back and forth to modify the elements. And that the iterators of this type have to support sortability. However, this is supported. For example, less than has to be supported. The sorting criterion has to be able to be used for these elements. So you get here, again, better error messages when you now use these libraries. So let's implement print. Print takes an input range. We want to iterate once over all the elements. That's the way we can write it now. We can pass a vector. We can print the collection. Awesome. Well, here it is. Here's the code. It's an input range declared with input range auto. Pass a vector, print call. And if you want to pass a set of int, it works. With ranges, there comes another nice feature, which is views. So there's support now to deal with a part of a collection or with the element or the values transferred somehow. So you can say, for example, let's print only the first 3 elements of this collection. We have a view for that. Well, we have a function that creates a view for that says just go to the collection, take the first 3 elements. That's it. And it works for both. Great. There's an alternative syntax. You will like it. It looks like that. Take the collection, pipe it into a take view so that the take view filters the elements, that only the first 3 of them are taken. And it works for both. Awesome. A lot of filters we have. We can filter and not just drop some elements, but elements that don't fulfill a certain criterion, or we filter them out. Or you can do that. Take the first 3 elements, take the value we then have, transform it to convert it to a string, append an s, and that should be printed to a generic print function. Nice. Who's done that already? Who's seen that already? Oh, only a few. Good. We even support sentinels. Sentinels is iterators and iterators. And these end iterators can have different types now. So you can do something like this. You can say, look at that. I have a vector. And I want to print all elements from the second element. So I initialize. This is also a view, a subrange, with the position of the second element. And the end should be an end value. The end value is -1. What the hell is that? Well, you can now print it, and you get these elements. You can pass this to take and transform, and you get these elements up to -1 as printed. Huh? The output is wrong, is it? There's an 11 missing. Bug on the slide. So 11s is missing. What is end element? This is end element. This is all you need. Yeah. Oh, it's not missing because of the take 3. Yeah, you're right. Thank you. Yeah, I'm ill. Yeah, thank you. I just wanted to find out whether somebody sees it. Good. Here's the end value. So end value has a surprising short implementation. It's an end value where we can pass a value that ends the iteration. And it has only a comparison operator, so we can compare it with, and the thing that is a parameter is a iterator. So we can compare it with a parameter by looking at the value of this iterator and looking at our value, and if both are equal, then yes, we have a value equal to what we were initialized with, well, what we were declared with, because our value is declared, part of it's a template parameter. So that is enough. Why is that enough? Well, look at how the range-based for loop works. The range-based for loop initializes the begin with what we pass, initializes the end with what we pass. These two things have different types. And then it iterates from begin to end. And it always compares the current position with the end, against the end, but using not equals. Hey, we didn't define not equal. We only defined equal, equal. And the order of the operands is also wrong. But there's a new rule in C++20, and the C++20 rule says, if a compiler finds an expression like that, pos not equal end, it will rewrite, and it cannot resolve it. Then the call will be rewritten now. So we will use equal, equal, maybe with the opposite order of the operands, and then apply not to that. And that's why this compiles. So yet another feature of C++ 20. Oh, a little bit of a side note. I used auto here as when I declared end value. And we have a new feature that is auto. So template parameters can now be data structures as long as they are public. So we can say, okay, here, let's use a coordinate, a data type that has X, Y, and Z coordinate. And let's create a subrange that goes from begin to the end value, which is the default initialized coordinate, so with the value 0, 0, 0. And that works fine. Good. Enough. Enough of this. Skip. Nope. I want to skip something. So, everything is great. Isn't it great? We can use begin and end of different type. We can use normal containers. We can print them out. We can take the first 3 elements. And yes, there are other views. We can drop the first 3 elements, of course. And we can drop the first 3 elements of a set or of a list. And oh. What? This does not compile? What the hell is going on here? Why does this not compile? We have 4 million programmers. 2 million of them will run into this trap. It works as designed. I was one of the first. Maybe I try this. Oh, that works. What? So I can call drop, but I cannot call drop as a parameter to print? But I can call drop for different container? What the fuck? Sorry, in the US, if you see that there. No, it's not allowed to say that. What is the problem? Drop has an implementation detail. The implementation detail is it caches begin if begin may become expensive. Well, begin for a vector is not expensive. Well, the begin of the drop. So drop has to ignore three elements. So to compute the begin of the drop, yeah, if the underlying range is a vector, we jump to the fourth element. Easy. But if we have something like a list, we have to iterate over all the leading elements. Oh, that's expensive. Maybe we need this view once again. Well, usually we do not, but maybe we do. Then begin should not iterate once again to the first element that fits this view. So we cache begin. Caching begin means while we are iterating, we are modifying the view. So it cannot be const. The problem is that print takes and makes the view const because it declares a const reference. Oh, okay. What can we do? I want to pass it by reference. So, well, if you remove const, you can no longer pass temporary objects anymore. But we have another thing, which is this thing, auto to ampersands, or template parameter to ampersand, which is called a universal reference because it can universally refer to different L values and R values, temporary objects and non-temporary objects, objects with a name, and it does not make the arguments const. By the way, the standard committee decided to name this forwarding reference, which is a huge mistake because they thought it's only for forwarding in move semantics. But this is not for forwarding. This is because we need a reference that can universally refer to everything. The term universal reference was coined by Scott Myers. I have no idea why the standard committee was not happy with that term. It was better than forwarding reference. Sometimes things like that happen. Okay, so this can universally refer to everything, not making it constant. Suddenly it compiles. Yay! So that means for all your generic code, if you want to pass containers and views, switch from const reference, const L value reference, const with 1 ampersand, to non-const and 2 ampersand. Easy. Just take all your code and make this adaptation. There's a question. Is the view expensive to copy? Oh, we could have passed it by value. And what is with the first two statements? I want to use this function to print containers. So if I want to pass a container, I have a problem. So, well, there's a caveat here. If you do that, if you make this fix, because they cache, that means that, and this caching of begin is not thread safe. If this function would use multiple threads to iterate over the elements, don't do that. Awesome design, I think. Is it worth it? No, it's not worth it. It's just about caching, and most of the times we don't need to cache the begin because we use the view only once. Okay, but this is a price. So yes, we can use by value. You propose that, but that would make calling print for containers expensive. There's another workaround. The workaround is require that it is a cheap range, a view. So, and if you do that, but then you can no longer pass a container. Well, there's a way to make a container, a reference to a container, which is also a view we have, which says, take all the elements of this container and give them reference semantics. And that is here. Though that is what you would have to do then. Choose your best bad choice. I don't think this is good design. We come back to this in a moment. Let's talk about threads, multi-threading, different topic. So this was one example. We come back. Let's random initialize some values that are in a vector. So let's write this function. It takes all the values as a template parameter. So this is code before C++20. We have to initialize a random device to have random numbers, and then we iterate over the values and we add a random value to them. Awesome. Will work. So what we can improve now in C++20 is a few things. First of all, we can say this code does not make sense if you can only iterate once over this range, because you need to do it twice, because you want to deal with the values in the vector then. So let's declare that the requirement is that what you pass here as an argument is a range you can iterate over multiple times, which is a forward range. Then we can also say there's a requirement that the values are integral, because we compute an integral random value, which we add. So that is a better requirement, unless, so we avoid that error messages in the middle of this code. Good. Let's use multiple threads. Okay. The first thing we do, we make this iteration a lambda, a helper function, locally declared, so we use a lambda. Then let's create a vector of threads, and each thread calls this lambda. We push it into the vector, and yeah, that's it, using std thread, which we have standardized in C++11. Well, almost everybody of you, if they have used std thread, know that you can't do it that way. There are several issues here. The most important issue is you get a call dump without calling join before the destructor of the threads is called. So you have, at the end, to add a loop that iterates over all the threads and waits for the end. That, by the way, is a violation of the RAII principle, that we should automatically clean things up in the destructor. For some good reason, but not the perfect reason. So the problem is this code is still broken for a couple of reasons. One is, if there's an exception in the middle, we will not come to the point where we call join for each thread. So this will have a call dump. Then it might be better to be able, if there is an exception, to stop all these threads. Maybe they run a long time. And then, of course, the worst thing is concurrent writes. Hey, we have multiple threads that modify the same elements in the past collection. Don't do that. Don't do that. So let's fix this all. First thing is use JThread. That's a new thread type in C++20. J stands for joining. The destructor will automatically join if you haven't done it yet. So that means this code has become more exception safe. But there's more. JThread has an option. You can, in your started function or lambda, add a parameter which is called a stop token. And if you do that, then the destructor will signal you stop. And you can process that in your code. You see in the loop where we iterate over the values, before we do something, we check, was that stop requested? And if there is, we stop processing. Because the problem is, if we have an exception, we won't have immediate reaction. And that is done now with this code, because automatically the destructor will not only call join, it will also, before it calls join, call request stop, which you can also do manually, by the way. So that makes your code safer. But we still have concurrent writes to the elements. How do we fix that? Or do we have to introduce new taxes, etc.? Oh no, there's something nice in C++20. Introduce a temporary atomic, make your values temporarily atomic by using what we call an atomic reference. So here, in this context, this is a context where we need atomicity of the values. When we access them, we make the values atomic before we modify them. And after that, and all threads, all concurrent access has to do that, otherwise it does not work. But it does not mean that the values are atomic in general. It's just temporarily atomic. Nice, I think. So everything is fine. What time is it? Okay. That was second example. We come back. Calendars and time zones. We have the chrono libraries in C++ 11. And now we have added some extensions. Most extensions are about dates, calendars, weekdays, time zones, etc. So the next higher level of time points and durations. So here's the code you can do. Let's initialize the first day with the 31st of January in 2021 and the last day. These are all different types. This is using the operator / to combine, for example, a year with an int. And what you get out is a year month. And if you then combine it with an int, you get a year month day. So it's a fully typed system here that makes sure that you don't do something not useful. And the same as with the last day here. And then we can iterate from first day to last day, incrementing the month. And let's have a party. Oh, this is the output. There's no party. Because February 31st, that's not a valid date. We blindly increment the month. That's how, for year, month, day, adding a month works. So, can we do it better? Yes. Well, first of all, you can write code that decides what to do. So, if the date is not okay, if the date is not valid, this library supports that you say, oh, in that case, let's take the first of the next month, the first day of the next month. Here's how you program that. The else part, take the year, the month, but use 1 and increment the whole date by 1 month. And let's have the party then there. Good. There's another way to do it. Let's iterate from the last day of January 21. So that's a different type. That's not a year, month, day. That's a year, month, day, last. So in that case, the logic is if we then increment things, then the month, we increment to the last day of the next month and the next month. So now we have that easier. Oh, and you don't like the output format? Well, we have a formatting library. Use it that way. If you want, you can apply time zones. So you can say, assume this is a local time, local date, or with local time at 18 hours and 30 minutes. Use the current time zone to print it out, and maybe invite the people in LA. And so apply this to another time zone and print it out, and you see what you have. Cool. I like this library. Yeah, I didn't show you all the traps. No, not traps, pitfalls. There are a few things you have to know if you use it, but in principle, this is a great library. Howard Hinnert, the designer of Chrono, is an awesome guy. Hi, Howard. What time is it? Okay. Let's combine everything. That's nice. Let's combine everything. So concepts, ranges, views. Oh, the Chrono library. Oh, multiple threads using JThread and atomic references. Let's combine everything. So at the end, this is a talk about the favorite C++20 example I have, not the multiple. We had this function random init. You remember? So we take a forward range. We require that the values are integral. And then we have an init helper function locally. So it's a lambda for, I don't have enough size on this slide, so there's ... for the code that initializes the random number generator. Because multiple threads use that, we use atomic references when we apply our modification, and then we use this initialization in a loop that iterates over multiple threads. No join is necessary at the end. Once all the threads are done, we call the destructors, and they will call join, and that's it. Well, let's create a map. And in this map, we have dates, so year, month, day, and numbers. How many items did we sell that day? Whatever this number means. How many visitors did we have in our cinema? I don't know. Yeah. So your key is the day. Your value is the value that applies to this day. Makes sense? Huh? I hope. Say yes, please. Good. Let's initialize it with some values. Oh, yeah, we learned how to do that. Let's start with the last day of January, and let's just take all the last days of the year. So start with the last day up for the whole year 2021 for each month, and place a new value there with this date and the starting value 0. So let's initialize this container. And now, let's simulate selling. So we call random init, and there is a view that takes from a pair the value. So from a key value pair, the value. This view is called values. So we pipe the elements. We take all the elements. We take only the values of them. But this is an error. Oh, too bad. I thought it would have been cool if this would have worked. What is the error, by the way? Do you know that? I have 10 minutes left. Is the error? Yeah, thank you. What is the error? So we don't wait 10 minutes. This creates a temporary object. And what we take is an auto reference. It's not allowed to have a non-constant reference refer to a temporary object or to an R value. But anyway, we have learned we should use universal references here when we iterate over something that might be a view or container. Yeah, so make it a universal reference, and it compiles. Yes. So here's the output. When we iterate only over the values, again, using this a view. So yeah, we can also now iterate over the elements, printing the date and the values. Here we only print the values. That's okay. Using this pipe semantics for views. Oh, that's cool. That's cool. That's cool. Let's. Can we skip the initialization of the first two elements? What do I have to do? Drop. Yeah. Call drop. Does it work? Yes. Awesome. Done. Thank you for your attention. Oh, wait a minute. There was something. It works. It compiles. It runs. You know what? This is a runtime error. So who can tell me what the runtime error is? Too many elements? No. This is a runtime error, and we designed C++20 that these errors can occur. Those who think this is a good design say that. They don't see a problem here. But this is the consequence that this code is broken. Why? Timur, you know that. You don't. You have standardized that. Yeah, nobody in the Senate committee knew what they were voting on when they accepted the proposal of ranges and views. It's a view problem. What did I tell you about that there is a danger when you pass a view to a universal reference? Don't use multiple threads then. Why? Because the view is cache. So what you have here is you create a view. This view is passed to random init. Random init starts 5 threads. They all call for the first time begin, and that is not thread safe. Because we cache the result of begin in the view. So this code is broken. I have complained. The standard committee does not see my complaint. Yeah. Let's make a thread-safe version. Well, the problem is you use a thread-safe version of something if you know that there's a problem. Ordinary programs will say, yeah, take works, drop works. Where's the problem? Where is the problem? Well, we only have that because we cache begin. And the price is that code like this is broken. And we almost never need a cache begin because we should use views ad hoc only once. Where? If we would not cache, we could iterate over views with const. If we would not cache, we would not have undefined behavior if somebody calls begin while another concurrently does that. Is this the right design decision? I think not. So how can we fix this code? Now, I want to know something. My best advice to fix this code is absolutely ridiculous. Because the problem of multiple threads is inside random init. Make sure we don't have a problem there. How do we do that? At the beginning of this function, we once call values.begin. and we don't have a problem anymore. Yeah, there are a lot of people who hate me because it looks like I make the standard committee look like a bunch of idiots. No, they're not. They are smart people, but sometimes we make mistakes. And the problem is, I think caching in views was a severe mistake. And here you see why. You might not agree with me. We can discuss that today or over this day or in the evening. I'm happy to get some input. But I fear that problems like this will happen. I think this is not good design. Maybe not very likely, but I see the price of caching in views is not worth the benefit of caching begin in views is not worth the price. Yep. Is it possible to remove that caching? Well, strictly speaking, we might break existing programs because you can also do things like count on that begin was cached, then insert on the underlying range new elements at the front, and then know that drop now no longer works on the second, but on the third element. I would consider code like that evil. But so I think, yes, we can fix that because we would allow things that were otherwise undefined behavior. I'm not sure I want to propose that because the standard committee is still not willing to fix the broken range-based for loop, so they don't care for broken stuff. If they don't have the problem, and they don't have the problem because they are experts, they know. Well, they know. Well, Timur, did you know that? Would you make this mistake? Okay. You have seen a lot of great things, concepts, that help you to decide which code is called. Concepts to get early error messages. Ranges and view support. Views that help you deal with subranges. The chrono library, an improved and fixed thread class. Temporarily atomic types. What else have we seen? Oh, the equality operator can now be used for not equal. Data structures can be template parameters now, non-type template parameters. Probably I missed a few things. So that's all what we have seen. Oh yeah, and chrono, calendar, and time zones. But time zones, yeah, oh no, we saw time zones. Formatted output with the format function. You have not seen everything, but that's it. And that's why this is my favorite example, because it's both really nice, but also a little bit frightening. Well, you can say that's good tradition in C++. Maybe it is. Thank you very much.